Okay, today is middle of December sometime. What is it? December what? 7th. This is MathLinks 8, your Chapter 6 Fraction, Multiplication, and Division Practice Quiz. Your first few questions are multiple choice. And the first one says, 3/4 times 2/5 is greater than 1. Is that true or false? And then when you think about it, without having to work it out, if we think about it as being 3/4 of 2/5, as opposed to multiplication, and I was to think about what that would look like, well, I'm having 2/5 here, so I cut it into fifths, and I'm saying I'm going to take, instead of having all of that 2/5, I'm only going to take 3/4 of that 2/5. Now we know that it is absolutely impossible to take less than 2/5, in this case 3/4 of it, and have a number that is greater than 1. So we can all automatically say the answer is false, because we know that 3/4 times 2/5, or 3/4 of 2/5, is going to be less than 1. And in fact, it's going to be 6/20, and therefore the answer is false. Question 2 says 1 2/3 times 2 is greater than 3. Now the answer for this one is true. And the reason why, if I think about what would be equal to 3, well, 1.5 times 2 would be equal to 3, if I think of it that way. So a fraction that is greater than 1.5, if I double that, has to be greater than 3 as well. So without actually working it out, I can figure out that this is true, because a number that's greater than 1.5 doubled has to be greater than 3 if 1.5 it doubled is 3. So you could also just work it out if you wanted to, and you could say that 5/3 doubled is going to be 10/3, which is equal to 3 and 1/3, which still makes it true. It is greater than 3. Your third question gives you an operation of addition and an operation of multiplication. Right off the bat, I know that it's probably going to be true, but we'll see how it works out. So 1/5 plus 1/4, if I find my common denominator, I'm going to end up with 9/20. Okay, 9/20. And 1/4 of 3/5 is going to be equal to 3/20. So when I multiply the numerators and denominators. And is 9/20 greater than 3/20? Yes, it is, so therefore it's true. Your fourth question says half of half is 1. And if I think, well, what does half of half mean? Well, half plus half is equal to 1, but half of half is multiplication. And half of half is not 1, it's actually 1/4, so the answer is false. Question number 5 says the reciprocal of 3.5 is 2/7. Well, we know that when we have mixed fractions, we have to examine them as improper first, and then we can get the reciprocal by flipping it upside down. So is the reciprocal of 3.5 2/7? Yes, it is. So therefore it's true. Doesn't look like it should be true, but it is. Question number 6 is a good estimation for the product of 2/3 and 3/5 is 1. So again, 2/3 of 3/5. If I think about that picture again, it's the exact same question I had before. So there is 3/5. And if I'm only going to take 2/3 of those 3/5, that's 1/3, that's 2/3. Well, 2/3 of 3/5 is going to be less than 3/5, because I don't get all of it. I only get 2/3 of the 3/5. So a good estimation for the product, meaning multiplication, of this and this is going to be 6/15, which is even less than half. So therefore, the estimation is not true, it is going to be false. Question 7, is this mixed fraction equal to this improper fraction? Well, if we multiply and add, we get 23/4. And 23/4 does not equal 27/4, so therefore this is a very easy false. They are not equal. The second one is the exact opposite. How many 2's are there in 13? There are 6 and 1/2. So since 6.5 does not equal 7.5, this one is also an easy false. Question 10 says multiplying a number by its reciprocal will always result in a zero pair. The answer for this is false. It will always result in the number 1. So if I take a fraction like 2/3 and multiply it by its reciprocal, I will end up with 6/6, which is equal to 1, right? The zero pair idea is when you add two numbers together. If you add a number and its reciprocal, you won't make a zero pair either. You make this bizarre number. So the answer is false. It will always result in the number 1. Oh, well, I guess we skipped number 9, so we'll do it now. The good estimation for 2 3/4 divided in half is 5. So if I say to you, we have $2.75 divided into piles of 50 cents, that would be an interpretation in decimal form of this particular question. Can I make 5 piles? Can I make 6 piles? No. So a good estimation with money is I can make 5 something, right? So is 5 a good estimation? Yes, it is, and therefore it's true. Another way to think of it is you had 2 3/4 pizzas, so there's 2 pizzas and 3/4 of a pizza, which is terrible for 3/4. How many fifths or how many halves could I get at a 2 3/4 pizzas? Well, in this particular pizza, I can get 2 of them. In this particular pizza, I can get 2 of them. In this particular pizza where I have 3/4 of a pizza, I can get 1/2 here, and then a little bit left over, right? So how many halves could I get from 2 3/4? I could get 5 halves and another quarter or half of a slice. Questions 11 on, or we're just dealing with multiplication. It says, doesn't say to model, it just says get an answer. So when we're dealing with multiplication of a fraction by a whole number, think of it as over that. Multiply your numerators and multiply your denominators. You get 2 2/5 as a final answer. When dealing with mixed fractions, the easiest way to multiply these out is to change it to an improper fraction and consider the whole number being over 1. Before you multiply the numerators and denominators, check to see if you can cross reduce. You can't. So you get 27 over 8, which is 3 3/8. Question number 13, similar. We're going to change this to improper, multiply by the whole number 2 over 1. Can't cross reduce, so I get 16/3, which is going to be 5 1/3. Now we have division of a fraction by a whole number. Now, when we learned this in the chapter, we actually thought about if you have 3/4 and we modeled it only. We didn't use an algorithm. But now that we know that 2 is really 2 over 1, we can keep the first fraction and multiply by the reciprocal to get the same answer. And as a result, the answer will be 3/8. Now, if I took that 3/4 and without using any kind of mathematical magic, if I took 3/4 and divided it between 2 people, me and my wife, I would get this much, which is 3/8 of the rectangle. When dividing a mixed fraction by a whole number, the easiest way to approach it is to change your mixed fraction to improper. And instead of dividing by 3, you're going to multiply by the reciprocal of 3, which is 1/3. And you get your final answer of 7/15. And God, this question looks so hard. It's a mixed fraction multiplied by a mixed fraction. When you have a mixed fraction multiplied by a mixed fraction, the easiest way to do it is change them both to improper. Examine for cross reduction possibilities. There isn't. So you end up with 21 over 8, which as a mixed fraction is 2 5/8. Question 17 is multiplication or division of fractions. Now remember, there are 2 ways you could do it. You could actually find an equivalent fraction of 20, which would be 4/20 divided by 15. Divide the numerators and denominators, you end up with 4 divided by 15, which gives you the final answer of 4/15, because your denominators would become 1. Or, alternately, you can multiply by the reciprocal and end up with the same answer of 4/15. Either way, the answer is 4/15. Question 18. This time we have a mixed fraction involved in the process. We're simply going to swap it there. And here we have a great example of when cross reduction is beautiful. 3 over 3 will become 1 over 1. 8 over 2 will become 4 over 1. When you multiply it all out, you get 4. If you did not choose that course of action and didn't cross reduce, you will end up getting 24 over 6, which is still equal to 4, regardless of how you got the answer. Question 19, we started getting some bedmass questions here. Some people still think you need common denominators when multiplying, but you don't. So the first thing I'm going to do is just keep my 1/4 and multiply this out to get 27/50ths. Now I have 1/4 plus 27/50ths. Common denominator will be 100. 25 100ths plus 54 100ths is equal to 79 100ths, which is your lowest terms. Question 20 is a bedmass question again. So here we're going to take 11/4 and subtract from it. I'm simply going to multiply by the reciprocal, subtract 2, right? Because 4/2 is going to become 2. Now at this point, I'm like, hold on a second. God, I wish I didn't change 2 3/4 to improper, because 2 3/4, if I kept it as 2 3/4 instead of 11/4, take away 2 is very easy, because 2 3/4 take away 2 is simply the final answer, which is 3/4, right? Now, if you didn't get that and you're like, well, I'm just all about process, 11/4 take away 4/2 is 11/4 take away 8/4, which is 11 take away 8/4, which is still equal to 3/4. But it's much easier to think of as 2 3/4 take away 2. Anyway. For question 21, we have mixed fractions up the wazoo. I'm going to change them all to improper to start. So 19/7 take away 3/2 divided by 7/4 will become, instead of 7/4, we're going to multiply by the reciprocal. At this stage, I'm going to go 19/7 take away 6/7, because I'm going to cross-reduce that, equals 13/7, which is 1 6/7. Now, question number, whatever this is, what is this, 22. Question 22, it says, at a baseball game, 400 people were in attendance. 2/5 are men, 1/8 are women, and the rest are children. What fraction of the people in attendance are children? So there's various ways you could do this. But if 2/5 plus 1/8 represents all of the men and women, right? Then if we add those two together, we're going to end up using 40 as our common denominator. Then 21/40ths are men or women, which means the rest have to be children. And if the rest are children, then that must mean 19/40ths are children. If 21/40ths are either a man or a woman, then the rest must be children, which means 19/40ths, or the rest of them. Or if you really wanted to do this way, you could go 1 take away 20/40ths equals the rest of them. And 1 would be, of course, instead of using the whole number of 1, we could use 40/40ths, which would end up being 19/40ths, right? So 19/40ths are children. Now, if there are 400 in attendance, the 19/40ths of the 400 people in attendance would be the number of children, or 19/40ths of 400, or even better yet, cross-reduce this to get 10/1, because both are divisible by 40. Then when you multiply that out, you get 190/1, or just 190 people. So therefore, 190 people in attendance were children. Question number 23 says, Alan makes $12 an hour, Bob makes 1 1/4 times as much as Alan, Cecil makes 1 1/3 times as much as Bob. How much do Bob and Cecil make an hour? So we know that Alan makes $12 an hour, and we know that Bob makes 1 1/3 times as much as Bob. So if we take the amount of money Alan makes, and multiply it by 1 1/4, that'll be how much money Bob makes. 12/1 times 5/4 will be 60/4. which is equal to $15 per hour. So Alan makes 12 bucks an hour. Bob is going to make $15 an hour, and Cecil makes 1 1/3 times as much as Bob. So Bob makes this, so we're going to multiply by 1 1/3. That's going to be 15 over 1 multiplied by 4 over 3, which is 60 over 3, which is equal to $20 per hour. So Alan makes 12, Bob makes 15, and Cecil, who must be very important, makes $20 an hour. It says if they each worked 4 hours and 15 minutes, how much would they be paid combined? So if I take Alan's money, which is $12, add it to Bob's money, which is $15 an hour, and add it to Cecil's money, which is $20 an hour, this bracket would represent the combined salaries per hour for all three people. So for 1 hour of work, you would have to pay out 47 bucks, right? To employ all three people. If you multiply this by 4 hours and 15 minutes, we have to think about 4 hours and 15 minutes in terms of a fraction. 15 minutes is what fraction of an hour? A quarter. So what we're really multiplying it by is 4 1/4, because 4 hours and 15 minutes is 4 1/4 hours. Now, obviously in the real world, we would never use a fraction. We would change it to 4 1/4 hours like this. So now we have a bed mass question. It's $47 for 1 hour multiplied by 4 1/4 hours. If I grab my calculator and say, what is 47 multiplied by 4 1/4? The answer is $199.75. So therefore, those three people to work at whatever place they're working at for 4 hours and 15 minutes, the employer would have to pay $199.75 to have them work for 4 hours and 15 minutes. Question 24. It says students in Mr. McDonald's class daydream for 2/5 of his class, which is probably true. That's an underestimation for some people. Of this time, 3/10 of it is spent dreaming of ways to earn more Will McDollars. Well, that was an old question. I think now we have jelly beans. So, Will McDollars, I used to use them back in the day as, like, if you did something good, it gave you a couple Will McDollars. You could save up and buy yourself a pop or a free bonus mark on a test. What fraction of math class is spent daydreaming of jelly beans? So if 2/5 of the time is spent dreaming and 3/10 of this 2/5 is spent dreaming about jelly beans, then 3/10 times 2/5 should be the operation that is jelly bean dreaming. When I work this out, it works out to be 6/50. 6/50, or in lowest terms, 3/25. Or, in terms of not lowest terms, but equivalent fraction out of 100, 12 out of 100. So really, when I look at that third fraction, that tells me that 12% of the class time here will be students daydreaming about jelly beans. 12% of my class, or 6/50 of the class, or 3/25 of the time in class. The second part says, if math class is 52 minutes, how much time is spent daydreaming about Will McDollars / jelly beans? So 6/50, let's use our lowest terms. Let's use 3/25. 3/25, that's not 25ths, that's 12ths. 3/25, or we said 12%. 12% of the 52 minutes in class would be 12%, or 3/25 of 52. Work that out, I get 156 out of 25, which is 6 at 6/25. So therefore, jelly bean dreaming occurs for 6 minutes and 6/25 of a minute. Now, 6/24 of a minute, how long would that be, 6/24? That would be a quarter of an hour, right? Or a quarter of a minute, 15 seconds. So roughly 6 minutes and a bit. So 6 minutes and 6/25 of a minute, or roughly 15 seconds-ish. And your last question, I think it's your last question, right? So as Jimmy cut 3/4 of his lawn, his brother Jamie cut 1/2 of the remaining lawn. How much of the lawn is left to cut? So remember our strategies. Think of an easier question. I'd like the drawing question. So I'm going to draw my lawn. I'm going to cut it into fifths. And I'm going to use the appropriate color. You know what? I'm going to use the appropriate shade of green. That appears to be a better shade of green. So Jimmy cut 3/5 of the lawn. Okay? This is Jimmy. Jamie, his brother, cut half of the rest. So Jamie did this one, and Jamie did this one. Okay? So how much of the lawn is left to cut? Just this part here. Well, how much is that? If I was to cut this over here, how much of the lawn is left to cut? According to my picture. 2/10, correct? Or half of 2/5. Because if you consider what was left to cut, after Jimmy cut 3/5 of the lawn, how much was left to cut? Just 2/5. So half of 2/5 is what that would be, which would be 2/10, which would be 1/5 in lowest terms. So this is left to cut, which is 1/5 of the entire lawn. Okay? Now here's where it gets complicated. If I said 1/5 divided into how many 20ths can you make from 1/5? How many 20ths can you make from 1/5? The correct operation is actually division. So 1/5 multiplied by the reciprocal is equal to 4. And that makes sense because really 1/5 as an equivalent fraction is 4/20ths, right? Because 1/5 and 4/20ths are equivalent. So 4/20ths has how many 1/20ths in it? The answer is 4. So therefore, 1/20th of the lawn, how many are there? There's 4 of them. 4 1/20ths. So therefore, 5 minutes each multiplied by 4 means that in order to cut 1/5 of the lawn, and 1/5 is equal to 4/20ths, it will take 4 5-minute increments or 20 minutes to cut the lawn.